Why is the sky blue?
The answer is easy to understand. It's just not simple.
First of all, is the sky blue?
Yes.
Okay. Well, at least we got that out.
Does it look blue to you?
It does.
Fine. That's what we're about to talk about.
All right.
Okay. So, here's the deal. The explanation is actually simple. It just takes a little while to explain.
Okay.
That's all.
All right.
All right.
I have time.
You have time?
I have some time.
Thank you. Thank you.
Yes, and boom.
All right. So, we have an atmosphere.
Okay.
We all know this.
Yes, we do.
Okay. It's composed primarily of nitrogen.
Okay.
78% nitrogen, it's 21% oxygen, and a few percent other, carbon dioxide, this sort of thing. Mixed in there are particles of like pollen and dust and sand from sandstorms and pollution and smog. And so
particulates.
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 Okay. Now, light comes from the sun. White light. People say the sun is yellow. It's white.
Right.
Okay.
Exactly.
You've seen the sun in the middle of the day. It's white.
It is white.
Okay. That's the proper color of the sun in the middle of the day.
Let's not get racist. It don't have to be the proper color.
Okay. It's just the color.
It's just the color.
Damn, Chuck, why is everything a race thing to you?
Because I live in America.
All right. So you may remember that white light is composed of colors.
Right.
Okay?
That's how prism.
That's how you get a rainbow.
All right.
The way our brain works and the sensors in your retina, okay? The rods, the cones. Yeah, the rods give you shades of light and intensity. The cones disentangle color.
Okay.
Okay? And you have an RGB cones.
Nice.
Okay, so we get RGB from.
Right.
You've heard that in computers
That's
and
right.
the computer screens and everything. Okay? So you are chemically, with the chemicals in your retina, splitting that red light into combinations of red, green, and blue.
Okay.
Okay? Broad combinations of these three. If you have more red than the others, then what you look at is going to look more red to you.
Right.
If you have more blue than the others, it's going to look blue. Now here's what happens. White light comes down from the sun.
Is that what it does?
The particles in the atmosphere, some of them are about the same size as the wavelength of blue light.
Sweet.
All right. Now, if you have a particle and light, and there's a particle is the same size as that light, it'll reflect.
That's right.
Or scatter. That's the proper word. Okay. Bounce, scatter, and so that light doesn't make it straight through. It sends in every other direction.
Oh.
So the light from the sun is selectively has the blue removed on its way down to Earth's surface, and the blue scatters into the air, and you have a blue sky.
That's very romantic.
It is beautiful.
The white light coming from the sun is a mixture of 7 primary colors, and each colored light has a corresponding frequency and wavelength associated with it. The violet-colored light has the shortest wavelength of all, while the red one has the largest wavelength. The Earth's atmosphere is mainly composed of gases, dust particles, water droplets, and water vapor. Among the gases, nitrogen is present in abundant quantity at around 78%. It is followed by oxygen, which is approximately 21%, and the remaining is filled with the likes of argon, carbon dioxide, and other gases. First, let's see what happens when the sunlight falls on these air molecules. When sunlight strikes these molecules, it gets scattered. Scattering is a process in which the light is absorbed by the atoms and re-emitted back in various directions. However, not all the light is scattered equally. The amount of light that will be scattered is given by the Rayleigh law of scattering. It says that the amount of scattered light or the intensity of the scattered light is inversely proportional to the 4th power of the wavelength of a wave. I is inversely proportional to lambda to the 4th power. If the value of lambda increases, then the intensity will be lower. If its value decreases, then the intensity of scattering will be more. Lesser the wavelength, more will be the scattering. So now, I want you to tell me, among the 7 colors of sunlight, which one will be scattered the most? Yes, the light of the color corresponding to the smallest wavelength will be scattered the most. So blue, indigo and violet light will be scattered most by these molecules of air. And when this light travels to our eyes, the sky appears blue to us. But wait, the violet light has the smallest wavelength. Then why doesn't the sky appear violet or even indigo for that matter? It is true that the sky scatters the violet light more than the blue light. However, we don't see violet sky, do we? What's the reason? The following graph tells us how much of a particular wavelength is emitted by the sun. Observe the graph well. As you can see, the sun emits more blue and light bluish light compared to the violet light. Hence, more blue light is scattered by the air molecules, resulting in the blue color of the sky. And another reason why we cannot see violet light is because our eyes are more sensitive to blue light than to violet light. So this was about how the gases present in the atmosphere scatter light. Do dust particles and water droplets also scatter light? Yes, they do. They scatter light as well. However, their size is comparatively much bigger than the size of the light waves. And hence they scatter all the colors of light in equal amounts. So the white light which is entering the cloud or the dust particles emerges out as white light again. Hence the clouds appear white.
Now, it's called Rayleigh scattering, a guy named Rayleigh. So here's the thing. As the sun gets lower in the atmosphere,
Right.
the path length of the light is much longer through the air. Okay? So in other words, so here's your atmosphere. If you're directly above, you're going through like this thickness. As you come down, the thickness gets more.
Right.
Okay?
Right.
Well, more atmosphere, more scattering.
Right.
The sky gets more blue. Okay? So in the daytime, it's, quote, sky blue. That's actually a pale blue.
Right, it's a very pale blue.
As you go to twilight, that sucker gets deep.
Yeah.
It gets deep blue. And so much more blue gets taken out of the sun.
I just love how violent deep blue is.
It's deep. And if you take out that much blue, the sun ain't got no blue light left at all. So what color is it going to turn?
Kind of red.
Kind of red.
Kind of red.
Kind of red, amber.
Yeah.
Okay? That's why sunsets are red.
Oh, that's
Because so much blue was taken out.
right.
That's all it has left to give you is the side of the spectrum where you have red, orange, yellow. So that's why we have a blue sky.
Nice.
Now, it's also why you can't see stars in the daytime other than the sun.
Well, wouldn't
It's,
that...
it's not, oh, you can't see stars in the daytime because the sun is out.
Hey!
That's not why.
Because the sun is brighter than the starlight that you would otherwise see.
No, that's not why.
Well, see, that's intuitive.
No.
That's how you would think.
It's intuitive, but it's wrong. Okay? The reason why you can't see stars in the daytime is because the scattered blue light has rendered our atmosphere aglow.
Nice.
The atmosphere is glowing blue light. And that prevents you from seeing the stars behind it. If you took away the atmosphere,
You'd be able to look up and see the sun.
the sun will be there, but then you like dark adjust over here, and there's full sky, full stars right over here.
Wow.
Over there, all around.